Mm. Assalamu alaikum students. As you entering the class, kindly first of all mark your attendance and turn on your camera. Okay. So class, we will wait for 2 minutes, then we will start the lesson. Okay, keep your books with you and open page number 100. Okay, we are going to solve the MCQs. So keep your book, calculator, and pencil with you. So So boys, you have your books with you. Uh, let's start the MCQs. Okay, we will take start from MCQ number 1. Okay, first of all, students, kindly open your camera. Ayan bin Faisal, your camera is not open. Kindly to on your video. Ali Ansar, also you have to on your camera. So we'll start the lesson. Ali Ansar, kindly turn on your camera. Okay. So boys, open page number 100. We are going to start MCQs of chapter number 13. First of all, the first MCQ is how many electrons form one coulomb charge, right? So we have to Find out the charge on the charge of 1 coulomb on the electron. So we know that 1 electron is equal to 1.6. Okay, boys, note down these values with the help of pencil on your book, so you can memorize later. 1.6 into 10 power minus 19 coulomb. So this is the charge on electron, and we have to find the value for 1 coulomb. So what will we do? We will divide this 1.6 into 10 power minus 6 on the other side, right? So it will be like this, 1.6 into 10 power minus 6. And here we will left with 1 coulomb, right? So take out your calculator and divide 1 divided by 1.6 into 10 power minus 9, and tell me what answer will you get. Take out your calculator, boys, hurry up. 1 divided by 1.6 into 10 power minus 9, and tell me what is the answer for 1 coulomb. Yes, Aryan sir, have you done? If you done, you can raise your hand so you can tell me the answer.
इसका आंसर 625,000,000.
Answer is 6. Yeah. Okay. Tell me the answer in standard form. Convert this value in standard form, then tell me the answer. It should be in points, okay, in standard form. Yes, Ayana, you have done. One divided by 1.6 in 10 power minus 9. And keep in mind, when you are trying to solve the denominator value as well, push the bracket so it will give you a right answer. So boys, what is the answer? Yes, Ayan bin Faisal. Yes. Yes, Ayan. I'm not hearing you. Please, can you speak clearly? Okay, boys, the answer is 6.25 into 10 power 18. See, if you just divide 1 by 1.6 into 10 raised to power 9, you will get the answer. Option D is right. 6.25 into 10 raised to power 18, okay? Now the question number 2 is, what is electrostatic force? So it means you have to find out the electrostatic force between two charges of 1 millicoulomb. So the value for charge is 1 millicoulomb separated by distance 1 meter. So we will use a simple formula that we have learned in Coulomb's law. So just write the formula. F is equals to K Q1 Q2 by R square. You know that the value for K is constant, that is 9 into 10 raised to power 9. And Q is same. Q1 is 1 millicoulomb and Q2 is also 1 millicoulomb. So the value for milli is 10 power minus 9. So put the value in the given equation, and R is 1 meter. So we have to take the square of this distance. So tell me what is the answer? Yes. 9 into 10 raised to power 9. 1 milli is 1 into 10 power minus 3. Again, we have the same value for Q, so we can take the square of this into 1 into 10 power minus 3 divided by 1 meter. So after calculating these values, we get the answer. Yes, Ali, answer, have you done? Ayan, if you done, kindly tell me the answer of statement of MCQ number 2. So if you just put the values, you will get the answer 9,000 Newton. Okay, circle the option B. Third is, if the distance between the charges is double, then force between them becomes. Okay, now they are asking that if we double the distance of charges, then what will be the effect on the forces? Again, we will use the same formula. F is equals to K Q1 Q2 by R square. And we have to double the value of distance between them. So if we take R as 2R, right? 2R means we double the distance between the charges. So if we put the value 2 over here, so its square will give us F is equals to K Q1 Q2, and this 2R square will be equals to 4 4R square, right? So if we just separate the F is equals to 1 by 4, in brackets we can write K Q1 Q2 by R square, right? So again, this is the value of electrostatic force. So it is equals to 1 by 4. So it's show that if we double the distance between two charges, if we increase the distance between two charges, the force will be 1 by 4. So the right option is option B. Mark the option, circle the option B. For B part, the answer is this, right? Now, the third MCQ is, fourth is, if a charge of 2 coulomb experience force of 10 Newton in the electric field of 5 coulomb charge, electric intensity at that point is, okay, in statement number 4, we have to find out the electric field intensity. So Ali Ansar, can you tell me what is the formula for electric field intensity? We have learned the class, electric field intensity. Yes, Ayan bin Faisal. What is the formula for electric field intensity? How can you write electric field intensity in a mathematical form? Why is formula for electric field intensity is E is equals to F by Q, right? So as we have to find out the value of electric field intensity, what will we do? We will put the value in this equation. So the value for force is 10 Newton. And for charge is 2 coulomb. Okay, we will use the charge 2 coulomb because this is a charge that experience the force of 10 Newton. Rather, we cannot use a charge of 5 second of that is a charge of electric field, right? So when we divide 10 by 2, we will get the answer 5. And we know that the unit for force is Newton, and the unit for coulomb is charge is coulomb. So we get the answer 5 Newton per coulomb. So mark option A. Option A is the right answer. If the potential difference between plates of a capacitor is reduced to half, the capacitance of a capacitor become. Okay, now we know that we learned the formula Q is equals to CV, right? And they're asking if the potential difference between plates of capacitor is reduced to half, then capacitance of a capacitance will be. So we have to find out the value of capacitance. So we will divide Q by V, which is equals to C. So if we have the potential difference of plates, so it will be Q divided by 1 by 2V, right? So this 2 we can take in the numerator, we will get Q by V. This is again the capacitance. So it's mean by If we have the potential difference, the capacitance will be double, that is equals to 2. So the right option is option number B. Mark the option B. Which will be double. Okay. MCQ number 6 is farad is a unit of. Okay, Ayan bin Faisal, kindly tell me what is the right option in statement 6, A, B, C, or D? Unmute yourself and tell me what is the right answer. Farad is the unit of. Yes, Ayan bin Faisal. Are you hearing me? Tell me what is the farad is the unit of which option, A, B, C, or D? First of all, unmute yourself. Yes. Okay, very good. Its the right option is option C. Seventh part is if two capacitors are connected in series, then capacitance of their combination will be increased, decreased, remain same, or always increase 4 times. Yes. What is the right option? We connect the capacitor in series, their combination will be decreases, because we know the relation 1 by C equivalent is equals to 1 by C1 plus C2 and so on. So in this case, the capacitance will be decrease. So the right option is option B. Mark 7B. Okay. Now the MCQ number 9 is if the capacitor of stored charge is 10 coulomb, when potential difference of 5 volt is applied, what will be the charge on capacitor if 20 volts are applied? So if we suppose charge of 10 coulomb is Q1, so Q1 is equals to 10 coulomb. Boys, wrote down these formulas or values which I'm writing with the help of your pencil in your book, okay? When potential difference of 5 volt is applied, so we can say that V1 is equals to 5 volt. What will be the charge on capacitor if 20 volts are applied? So we have to find out the Q2 if V2 is equal to 10, 20 volts, right? So boys, we have learned the formula during taking the class in the school. Q is equals to CV, right? So with the help of this formula, what will we do? First of all, we will find the value of this capacitance. So if this Q is equals to CV, suppose this is Q1 and this is C is equals to V1, right? So as we have to find out the value for this C, so we will take this V1 on the other side and it will be divide. Q1 V1 is equals to C, right? Now put the value of Q1 and V1 in this formula. The value for Q1 is 10 coulomb and put the value for voltage V1 is 5 coulomb. So 10 divided by 5 gives you 10 divided by 5 is equals to C. Yes, Ali answer, tell me what is the answer of this capacitance? 10 if you divide 10 by 5, what will you get the answer? Unmute yourself or and tell me the answer. 2. Okay, so the value for this capacitance is 2 farad, right? Now, what will we do? We will use this value. Capacitance is 2, right? Again, we will use the same formula, that is Q is equals to CV, right? Now, we are going to find out the charge Q2 on the voltage V2, right? We have both values. Capacitance is equals to 2 and voltage is 20. So solve this equation. What will the value of Q2? Yes, Hassan, can you tell me what is the value on charge Q2? Unmute yourself and tell me the answer. Yes, Hassan. Q2. Yes, Hassan.
2 coulomb.
Sorry, what is the answer?
2 farad.
2 multiplied by, okay, it's 2 farad, but again, we will use the same formula to find out the charge on voltage, that is 20. So we use the formula Q2 is equals to CV2. We put the value of capacitance is 2 farad and V2 is 20. So if you multiply 2 with 20, what will you get? Yes, Hassan?
40.
40. Okay, good. So the right answer is 40 coulomb. Mark option C. So in problem number MCQ number 9, the right answer is option number C. Okay, we left the MCQ number 8, which is a vector quantity: electric field intensity, electric potential, potential difference. Option D is capacitance. Yes, Areeb, can you tell me which is the vector quantity from the following options? Give me the right answer. Yes, unmute yourself and tell me the answer. Which is a vector quantity? Choose the right option from A, B, C, D, and give me the reason. Right option is option A, electric field intensity, right? As we know that E is equals to F by Q. So F is the vector quantity. It's mean electric field intensity is also a vector quantity, right? So you can mark the option A, electric field intensity is a vector quantity, right? Now, option 10 part is which of the following is touched with disc of charge electroscope, but gold leaves of electroscope do not collapse. The 4 options are given to you and tell me which option is right. Because if one of them touched to this charge electroscope, the gold leaves will not collapse. Yes, boys, what will be the right answer? Option A is paper rod, option B is steel rod, option C is copper rod, and option D is graphite rod. Yes, Hansla, can you tell me the answer?
Paper rod.
Yes, very good. The right answer is paper rod because paper rod is an insulator. If we bring the steel rod, copper rod, and graphite bring closer to the charge electroscope, what will do? The gold leaf will be collapsed because they are the conductor. So the right option is option A. Now I will just summarize the answers of these MCQs because some students they join the class late. For MCQ number 1, all right, option is option D. Mark if you didn't mark yet. Right option is option D. 1, D. For 2, right answer is part B, 9,000 Newton. For 3, right answer is option B, 1/4. For part 4, the right option is option A, 5 Newton per coulomb. For 5, the right option is option B. For 6, right option is C, capacitance. For part 7, right option is option B, that is decreases. For 8, right option is option A, electric field intensity. For part 9, the right option is option C, that is 40 coulomb. And for 10, the right option is option A, paper rod. Okay. So if any confusion in these MCQs, kindly raise your hand and you can ask me any problem. Otherwise, we'll move to the next slide. Okay. So You have to solve these MCQs in your notebook. Just understand here, and then after copy from these slides in your notebook. I will check these numericals on Monday, inshallah. Okay. The first problem is how many electrons are removed from a metallic sphere charge. So the charge, okay, keep your book with you. First problem is how many electrons are removed from a metallic sphere to get 100 pico charge, right? Charge is given to you 100 pico, right? So we write the charge over here, that is Q is equals to 100 pico. We know the value of pico is 10 power minus 12. So 100 multiplied by 10 power minus 12 coulomb. Okay. Now we are going to find out the charge on electrons. How many electrons are removed, right? So we know that the charge on electron is represented by E, which is equal to 1.6 into 10 raised to power minus 19 coulomb. Boys, learn this value because this value is constant. The charge on electron is always 1.6 into 10 power minus 19 coulomb. And we have to find out the number of electrons, right? So we know that Q is equals to number of electrons into NE. We have to find out the value of N. So bring this E on the other side. So N is equals to Q by E. We get this formula. Put the value in this formula. 100 multiplied by 10 minus 12. This minus 12 is the power, okay? Divided by value of electron, charge on electron is 1.6 into 10 power minus 19. Minus 19 is again the power, okay? Put it in the power. So after calculating with the help of a calculator, you will get 6.25 into 10 raised to power 8 electrons, right? This 8 is also a power. This is the problem number 1. Now, the problem number 2 is 2-point charges of 1.2 pico coulomb and 2.5 pico coulombs are separated by 50 centimeter distance. It means the two charges given. One is Q1 1.2 pico coulomb and second is Q2 is equals to 2.5 pico coulomb, right? And they are separated by a distance R is equals to 50 centimeter. So what we have to do, first of all, we will convert distance into meters. So 50 divided by 100 give you 0.5 meter, right? Again, we have to find out what is the magnitude of force between 2-point charges. Again, we will use the same Coulomb's law. So Coulomb law is F is equals to K Q1 Q2 by R square, right? So K is 9 into 10 raised to power 9. Q1 is 1.2 into 10 raised to power minus 12. Minus 12 is a power, okay? And Q2 is 2.5 into 10 power minus 12. And take the square of the distance 0.5 whole square. So if you will take the square, you will get the answer 54 into 10 power minus 15 Newton, right? This is the problem number 2. Now the problem number 3 is force of repulsion between two identical point charges is 100 Newton. So force is given, that is 100 Newton. When distance between them is 40 centimeter, the distance between these two charges is given as 40 centimeters. So we will write the distance over here. R1 is equals to 40 centimeter, divide 40 centimeter by 100. We will get 0.4 meter. What is the force of repulsion between two charges if the distance is doubled? Now we have to find out the force when the distance will be doubled. So if the distance is doubled, it will be R2. So we will multiply 0.4 with the 2 to double the distance and we will get 0.8 meter, right? Now, as we, first of all, we will use the force F1 and R1, right? To find out the value of charge Q, right? When we find the charge Q, then we will use these charges to find out the force F2. Okay, got it? Now we will use a formula F1 is equals to K. This is a formula. F1 is equals to K Q1 Q2 by R12. This 2 is basically the square, right? Keep this 2 in the power. The distance is R1, but this 2 is in the power. So the value for K is always constant. That is 9 into 10 raised to power 9. And the charge is not given to us. So we write Q and Q. Our distance is 0.4. Okay, by putting this value, By putting this V value, we will get the Q square is equals to 1.78 into 10 power minus 9. Okay. So just use the formula F again. You will use again use the same formula. F2 is equals to KQ square by R square. 9 put the value of K is 9 into 10 is to power 9, and Q square we calculated in the previous slide, that is 1.7 into 10 is to power minus 9. This is minus 9 power, and distance is 0.8 whole square, and we will get the value 25 Newton. This is the force that we needed to calculate. Alian sir, beta, please turn on your camera. It's not allowed that you have turn off your camera. Okay. Now okay, boys, those who came late, kindly mark your attendance in your chat box. So later I can keep you the record of your attendance. Okay. So the problem number 4 is two identical charges separated by 10 centimeter experience electrostatic force of 250 Newton. Find the magnitude of charges, right? The two, it means that charges are identical and the distance is R, that is 10 centimeter. So if we divide 10 centimeter by 100, it is equals to 0.1 centimeter. Okay, class, or are you getting? So force is given to us. Yes, Arif. Yes.
chat disable है.
Disable? Okay, wait, let me check. No, it's okay. Wait, let me check what is happen. Okay, now you can mark your attendance in the chat box. Arey boys, mark your attendance in your chat box. Okay. Okay, so the distance is 0.1 meter. We have to find out the charge. Okay, the charges are identical. It's mean we have to find out, we can suppose the charge Q1, Q2 is equals to Q. Again, we will use the same formula, that is F is equals to K, Q1, Q2 by R square. Put the value of K. K is always constant. Okay, that is 9 into 10 is to power 9. This 9 is in power. Put the charges Q divided by 0.1 whole square. Then Q is equals to okay, when you get the answer is in term of Q square something, right? Take the square root on both sides and you will get the answer 1.67 into 10 raised to power minus 5 coulomb. Okay, so this is the problem number 4. Then see the problem number 5. 90 joule of work done to move 90 joule of work done. So we put the work done 90 joule of to move 2 coulomb charge. Charge is 2 coulomb between 2 points having potential difference, right? Potential at point at lower potential has electrical potential of 13 volts. So this is 13 volt is as lower potential. So always keep lower potential as V2 or suppose it as VB, right? Find the electric potential of other point. It's mean we have to find out the electric potential at higher point. It's supposed to be V1. So we know the formula delta V is equals to W by Q. Delta V is V1 minus V2 is equals to, put the value, W is 90 and charge is 2. So V1 we write as it is. Put instead of V2, put the value that is 13 is equals to 90 by 2 gives you 45. Take the minus 13 on the other side, you will get V1 is equals to 45 plus 13. So this is equals to 58 volt, right? So this is the right answer. Okay. The next problem is problem number 6. Problem number 6 is given as Two capacitors of capacitance 5 microfarad and 10 microfarad are connected in parallel with a 20 volt batteries. Find equivalent capacitance of combinations, total charge stored on combinations, charge on each capacitor, and potential difference, right? So C1 is given as 5 microfarad. Open the value of this micro, you will get 10 into 10 raised to the minus 6 farad. V is 20 volts, right? So when the capacitors, they are connected in parallel, we know the formula C equivalent is equals to C1 plus C2. Put the values and you will get the answer 15 microfarad. Now we have to find out the charge on these capacitor, and we have to find out the total charge, right? So we know the formula for charge is equals to Q C equivalent V. Q is equals to C, put the value of CE, that is 15 into 10 raised to the minus 6, right? And V is 20. After solving this, you will get the answer 300 microcoulomb, right? So part C is you have to find out the charge Q1 and Q2. So we know that in case of parallel circuit, the charge is always divided, right? So Q1 is equals to C1V. We use put the value of C1 5 into 10 raised to the minus 6. Voltage is same, that is 20. When you multiply this, you will get the answer 100 microcoulomb. Similarly, we can find out the value on charge Q2. Q2 is equals to C2V. C2 is 10 into 10 power minus 6. Volt is 20. So this is 200 into 10 power minus 6. So we get the answer Q2 is equals to 200 microcoulomb. Okay, now in fourth part, we have to find out the voltage. Now we know that when the charges, they are connected in parallel circuits, the voltage will remain same. The voltage is not divided. So the voltage on V, which is equals to V1, V2 is 20 volt, right? Okay. The next part 7 is two capacitors. If you are not seeing clearly from the slide, you can also see the question with the help of your book, which is right on page number 102. Two capacitors of capacitance 3 microfarad. Okay, the capacitance is given to you 3 microfarad and are connected in series with a 6 microfarad. The other capacitance is 6 microfarad in series with a 10 volt battery. So the voltage value for voltage is 10 volt, right? So we have to find out the equivalent capacitance of the combination. We have to find out the total charge on the combination, and then charge separately on each capacitor, and then potential difference across each capacitor. So we know that in case of series, the formula is 1 by C is equals to 1 by C1 plus 1 by C2. Put the values in this. We'll get this. Then first take the LCM of these values. So we can write this is 3 and this is 6. So if you take the LCM, it is 3, 1 into 2. So you write 2 over here and 1 over here. 2 plus 1 gives you 3. 6 divided by 6 into 10 raised to power minus 6. So CE is equals to 6 into, okay, just if we take the reciprocal of it, we have to invert this value, and we will get, if we just invert this value, we will get CE is equals to 6 into 10 power minus 6 divided by 3. So 6 divided by 3 gives you 2 into 10 power minus 6, which is equals to CE is equals to 2 microfarad. Now we have to find out the charge. So total charge is Q is equals to CEV. Put the value of this CE over here. We know the voltage is 10. Multiply them, you will get the answer 20 microcoulomb. This is the total charge. Okay. Now, in same way, we know that the charge on the capacitor will remain same in series. So the charge Q2, Q1 is equals to 20 microfarad. We can find out the V1 by applying the formula Q is equal to C1 V1. V1 is equals to Q by C1. Put the value of Q, C1, we will get the answer 6.67 volt. Similarly, for Q is equals to C2V, as we are going